In this lesson, we are going to explore the structure and bonding in metals. Do you know a property that all metals have in common? Well, they are all good conductors of both electricity and heat. But first, let's recall the formation of ions from metal atoms. Do the atoms of metals tend to lose or gain electrons? Correct. Metal atoms lose electrons. So are the ions formed by metals positively or negatively charged? Excellent. They are positively charged. The fact that these atoms lose electrons means that they are losing the negative charge, and that's why the formed ions are positively charged. In the simulation here, we are demonstrating the property of metals in conducting electricity. Metallic bonding involves each metal atom donating electrons into a sea or a cloud of electrons that bind the metal together. These electrons come from the highest occupied energy level, which is the outermost shell of the metal atoms. And you can see them moving in the simulation around the atoms. Because they are free to move around within the structure of the metal, as you can see, they are called delocalized electrons. So all the electrons that you can see moving in this simulation are called delocalized electrons, and they are donated by the metal atoms into this sea of electrons. So in conducting electricity, these delocalized electrons will move in the direction from negative to positive because electrons have a negative charge, so they will be attracted to the positive charge. This movement of the delocalized electrons gives the metal the property of conducting electricity. Now let's demonstrate conducting heat or conducting thermal energy. This is a metallic rod, and the above diagram is the metal. You can see the metal atoms and also the delocalized electrons moving in the sea of electrons. If we heat the metal rod, you can see that the delocalized electrons are moving very fast. This fast movement allows the conduction of heat. So it's all about those delocalized electrons in metallic bonding. The delocalized electrons and their free movement allows conduction of electricity and conduction of heat. As you probably know, most metals have high melting points. So this suggests that there is some kind of bonding throughout a sample, not just between small groups of atoms. In fact, metal ions form extended three-dimensional lattices, with the electron sea forming delocalized bonds that hold the metal ions in place within the lattice. So in this figure you can see the face-centered cubic lattice. This is the hexagonal close-packed lattice and the body-centered cubic lattice. The body-centered cubic lattice has the most space within its lattice.